CV4. Okay, let's do the spelunker question. Except we're gonna give him a mass. Okay. So let's say that we've got. Well, no. Let's just do part of the spelunker question. Let's just make one up. Okay. So in this question, we've got an object that's being accelerated upwards by a force. Okay, it's being accelerated upwards by a force, and we'll give it a mass of 100 kilograms. We'll say that the accelerating force is 1,500 newtons. And we want to figure out what is the work done by the force which is pulling it upwards. Like this is, say, an object being pulled upwards by a rope or a cable or something. And then what is the work done by gravity? What is the net work? Okay. And also, assuming it starts from rest, what is the final velocity of the object after, oh, and we'll also say that it's been pulled the distance of 10 meters. Okay. All right, so the work done by this force up here. Can we actually do this? I'm kind of making it. Yeah. Yeah. Sorry. Okay, so the work done by that force will be that force, which transfers energy to the object. Just call it F. And that force is acting over a certain distance. Yep.
I have a question. So when you do the forces, is it the net force or just
when you work is always done by a single force.
Okay.
The net work is all the work, positive and negative, all added up. But the other way you can do it, it's mathematically the same, is that the net work will equal the net force multiplied by the distance. They're mathematically equivalent ways of thinking about it. But work is always done by a single force. Okay, so we have the work done by this force, which is pulling upwards, which is going to be that force times the displacement. So it's going to be the 1,500 newtons times the displacement 10. So we have a work done of 15,000 joules. All right, now let's find the work done by our force of gravity. Work done by our force of gravity. Well, first of all, it's acting in a direction opposite our displacement, or the direction of motion. So is it positive or negative work?
Negative work.
Okay, so it's going to be negative. We'll just go ahead and put the negative right in there. If you use the FD cos theta equation, you'll put 180 in for theta, and then cos 180 is negative 1. Same thing. I prefer to just reason about it. Okay, now that force of gravity will be mg. It'll act over d. So we have negative 100. We're going to call it g10 times 10. We have negative 10,000.
Wait, G is 10?
G's 9.8. I'm rounding it to 10 because I don't want to blow my calculator for a simple example. It's about 9.8. In fact, that would be G to one significant digit, wouldn't it? All right. Okay, so then our network. Positive work is like putting water into the jug. Negative work is like taking water out, right? So if I put 15,000 milliliters of water into my jug, and then Avni takes 10,000 milliliters out, then what's the net amount of water left in the jug? It's just those two numbers plus each other.
So 5,000.
That's right. So 15,000 joules minus 10,000 joules coming out means that my net work is 5,000 joules. Okay? So let's find V2 now, which is the speed of the object after it's traveled 10 meters. So now that we know the net work, I guess we'll talk about what Andrew, just a little sidebar over here, we're just going to talk about what Andrew asked about. Okay, another way to think of the network, it's mathematically equivalent to what we just did, is the net force times the distance. The net force would be the upwards applied force minus the weight so you see how it gives us the exact same expression. FD is that, right? And GD is that. Okay, so you could have done it either way. All right, so let's go over here and let's find the velocity of this object. So the work energy theorem says that if there is net work done on an object, meaning there's energy transferred in or energy transferred out, we're going to see that as a change in its kinetic energy. And that's mostly pretty common sense, right? If I put energy into something, its motion is going to change. If I take energy out, its motion is going to change. It's going to slow down. So that net work will be EK2 minus EK1, final kinetic energy minus initial. We know the initial kinetic energy is 0 because I said it started from rest. So here, you know the net work, you know the mass. It's simple to solve for the speed of the object after it goes 10 meters.